Hi, boys and girls. Today I would like to talk about the fat-soluble vitamins. This is another nutrients that we need, right? If you still remember, we have learned carbohydrates, proteins, what else? Yeah, the lipids, right? And these are the main nutrients that we need, give us energies, and we have very important function. Today, we'll talk about another tips that is fat-soluble vitamins. Vitamins, there are two main types. One is the fat-soluble one, the other is the water-soluble. Today, this topic will mainly focus on the fat-soluble, and then next, okay, we will talk about the water-soluble ones. Now, let's start. Yeah, here, let's out the main components of the food. We will finish the topic on carbohydrates and proteins, lipids, right? Do you remember the functions of these three? The structures, the composition, and uses, all these. Do you remember them? I hope so. And now we take a look on the fourth one, which is the vitamin. For the vitamins, and I would say, okay, vitamins are essential organic compounds and we need them, but not in large amount, just in small quantities. And so for the vitamins, wow, there are in total 13 known vitamins. Do you know all of them? I think you know some of them, right? Probably you heard vitamin C, which is the most common one. We need it, especially nowadays. We need vitamin C. What else? Yeah, we have vitamin A as well. Any more besides vitamin C, A? These are common ones. Yeah, vitamin D, very good. And as I said, there are two main types. One is the fat soluble one. The other is the water soluble one. In total, there are 4 fat-soluble vitamins. They are A, D, E, K. For the water one, that will have the vitamin C and vitamin B. B is in a complex form. There are vitamin, okay, are there in total 8 types, okay, for the vitamin B. Now, let's see. Most of these vitamins, they are discovered due to the deficiency disease. And once the disease reported, okay, we discovered all that because of lacking of some of the vitamins. So we discovered that. And okay, for the vitamins, we use the alphabets A, B, C, D, right, and name them. Yeah, it's true. Okay, they are assigned with the letters in the order of discovery. Let's say, for example, vitamin A is the first fat-soluble vitamin to be identified. So, okay, assign with the first alphabet letter A. Some later found vitamins, they are in the form of mixtures. And now, about the vitamins, I would like to share a video with you and get a general idea, more information about the vitamins. Now, let's see.
A, C, E, D, B, K. No, this isn't some random out-of-order alphabet. These are vitamins, and just like letters build words, they're the building blocks that keep the body running. Vitamins are organic compounds we need to ingest in small amounts to keep functioning. They're the body's builders, defenders, and maintenance workers, helping it to build muscle and bone, make use of nutrients, capture and use energy, and heal wounds. If you need convincing about vitamin value, just consider the plight of olden-day sailors who had no access to vitamin-rich fresh produce. They got scurvy, but vitamin C, abundant in fruits and vegetables, was the simple antidote to this disease. While bacteria, fungi, and plants produce their own vitamins, our bodies can't, so we have to get them from other sources. So how does the body get vitamins from out there into here? That's dependent on the form these compounds take. Vitamins come in 2 types, lipid-soluble and water-soluble.
Yeah, do you still remember? I just mentioned, right? There are 2 main types.
and the difference between them determines how the body transports and stores vitamins and gets rid of the excess. The water solubles are vitamin C and B complex vitamins that are made up of 8 different types that each do something unique. These are dissolved in the watery parts of fruits, vegetables, and grains.
Yeah, okay. They are water soluble ones, so you can expect they can be absorbed easily, right? And transported easily as well.
Meaning their passage through the body is relatively straightforward. Once inside the system, these foods are digested, and the vitamins within them are taken up directly by the bloodstream. Because blood plasma is water-based, water-soluble vitamins C and B have their transport cut out for them and can move around freely within the body. For lipid-soluble vitamins, dissolved in fat and found in foods like dairy, butter, and oils, this trip into the blood is a little more adventurous.
Yeah, because they are the fat soluble ones. And to transport absorption, I think it will be more difficult than the water soluble ones. Do you agree with that?
These vitamins make it through the stomach and the intestine, where an acidic substance called bile flows in from the liver, breaking up the fat and preparing it for absorption through the intestinal wall. Because fat-soluble vitamins can't make use of the blood's watery nature, they need something else to move them around. And that comes from proteins that attach to the vitamins and act like couriers, transporting fat solubles into the blood and around the body. So this difference between water or fat-soluble vitamins determines how they get into the blood, but also how they're stored or ejected from the body. The system's ability to circulate water-soluble vitamins in the bloodstream so easily means that most of them can be passed out equally easily via the kidneys. Because of that, most water-soluble vitamins need to be replenished on a daily basis through the food we eat. But fat-soluble vitamins have staying power because they can be packed into the liver and in fat cells. The body treats these parts like a pantry, storing the vitamins there and rationing them out when needed. Meaning we shouldn't overload on this type of vitamin because the body is generally well stocked. Once we've figured the logistics of transport and storage, the vitamins are left to do the work they came here to do in the first place. Some, like many of the B-complex vitamins, make up coenzymes, whose job...
Yeah, you will find that they have their unique function. So I think, okay, you should know the functions of the vitamin B, C, D, E, K, all these, right? Let's take a look.
It is to help enzymes release the energy from food. Other B vitamins then help the body to use that energy. From vitamin C, you get the ability to fight infection and make collagen, a kind of tissue that forms bones and teeth and heals wounds. Vitamin A helps make white blood cells, key in the body's defense, helps shape bones, and improves vision by keeping the cells of the eye in check.
Yeah, today we will take a look on the vitamin A and just the function of it, right? Do you still remember? And for the question, I think you know some of them.
Vitamin D gathers calcium and phosphorus so we can make bones. And vitamin E works as an antioxidant, getting rid of elements in the body that can damage cells. Finally, from vitamin K, we score the ability to clot blood, since it helps make the proteins that do this job. Without this vitamin variety, humans face deficiencies that cause a range of problems, like fatigue, nerve damage, heart disorders, or diseases like rickets and scurvy. On the other hand, too much of any vitamin can cause toxicity in the body. So there goes the myth that loading yourself with supplements is a great idea.
Yeah, we need vitamins, but we can't take too much. So too much of it will be toxic.
In reality, it's all about getting the balance right and hitting that vitamin jackpot.
So I hope you enjoy watching the video. And now, for the fat-soluble vitamins, do you still remember which 4 are fat-soluble ones? Yeah, good. And they are the A, D, E, and K, right? So, for these, fat-soluble ones, and they will be absorbed the best, when we take in the high-fat food. because they are fat soluble. And they'll be stored in the fatty tissues and the liver for the future use. If too much of the fat soluble vitamins and wow, as I just said, and it's not good. Okay, I need to toxicity, right? So that's why we need just a small amount. We need some, but not too much, right? And so for the fat soluble one, because get rid of them, it's not as easy as the water soluble one. So that's why we do not need to take in every day, maybe just for this a week or a month. For the water soluble ones, and they are the called vitamin C and the B complex, and that will be discussed in the next chapter. Okay, first we will talk about the vitamin A. Vitamin A, there are two types. And the first one, that is the retinol. Retinol, it can be found in the animal food. I would say retinol is a form of vitamin A, and that can only be found in foods from the animals. So the body can use the retinol to convert it into the retinol and retinoic acid. And these are the other forms of the vitamin A. They have different function. For the retinol form, and it's essential for the vision. But for the retinoic acid form, it's essential for skin health, teeth remineralization, and bone growth. So that is the first thing, retinol. And what kind of food can get this vitamin A? Let's say for the fish oil, let's say for the liver, or for the eggs. We got the retinol is easily obtained from food. Besides retinol, we have the carotenoids, and carotenoids is the we'll call it the provitamin A. And this type of vitamin A can be converted to retinol. It's found in not animal food anymore. It's found in the vegetables. Let's say the carrots, Spanish, papaya. We got the carotenoids, and gives the color of the food. The most common type of the carotenoid, that is the beta carotene. And sorry, there's a typo. It's a TYPE. Tape. And it's less easily absorbed than the retinol, so it must be converted to the retinol and the retinol by the body before the absorption. Vitamin A is important to us. How much we need? About the amounts, we will use RAE as a unit to quantify the vitamin A. RAE. That is retinol activity equivalent. 1 RAE equals to 1 microgram of retinol, and it's also equal to 12 microgram of beta carotene. Here you see a symbol. Do you know the meaning of it? That is micro. Micro, that's times 10 to the power -6 gram. Just a small amount. We just need a small amount of it. And now, for the vitamin A, it's quite essential for the visual pigment, and we need it for seeing, right? Now let's have a summary. For the vitamin A, there are two main types. One is the retinol, and the other is the carotenoids. For the retinols, we got it from the animal food, the foods from the animals. Let's say the beef liver, the eggs. We got the retinol. For the second one, that is the carotenoid, that from the plant source. For the vitamin, and it composed of the carbon, hydrogen, oxygen, just like the carbohydrates, just like the lipids, right? But this one from the protein, because for the protein, we have one more element, that is the nitrogen. And for the carotenoid, okay, give the color of the food, let's say the red color, orange pigments, yellow pigments, and just because, okay, of the carotenoids present. Let's say the carrots, what color is it? Yeah, it's orange, right? And so the most common one is the beta carotene. And besides the beta one, we still have others. And as I just said, if we talk about the amount, we will use RAE. Then one retinol activity equivalent, one RAE is equal to 1 microgram of retinol, 12 microgram of beta carotene, or 24 microgram of other carotenoids. Well, you know, okay, for the vitamin A, okay, it's essential for the visualization. So how we can see, how can we can see things around us? Because okay, we need this vitamin. Vitamin A combines with the protein opsin to form the rhodopsin, which is a whistle pigment, or you may say, okay, it is a light absorbing molecule. And this light absorbing molecule can be found in retina. Okay, now here I showed you a diagram of the eyeball. And can you find the retina? Yeah, that's the layer here, right? And so in the eyeball, there's a layer, that is the retina. And the retina, you know, in the retina, we'll find the cells. Okay, inside the cells, we'll have the photoreceptors. The use of these photoreceptors, that is to absorb the light. And we found the whistle pigments over there. These whistle pigments, that is the rhodopsin. And the rhodopsin absorbs the light, and after absorbing light, it will change its shape. And now I showed you. Here, you find the retinal in the photoreceptor on the cells, and it's in the cis form. Do you still remember the cis form? Cis double bond. Yeah, okay, we'll have the hydrogens on the same side, right? And these are the cis. Let me mark it down. Okay, and these are the hydrogens, and they're on the same side. Okay, that is the cis. Cis form. For the cis form, after absorbing the lights, and then it will convert it to what? It converts to trans. So it changed the shape of the chain, right? So after that, and once the light enters the eyes, the cis retinal will absorb the light and then convert and change its shape to the transform. So after this, it will induce a nerve signal to the optic nerve and send it to the brain so that we can see something around us. Okay, it's easy to understand. Now, let's see. Okay, back to this page. As I just said, once absorbing the light, then the double bond changes from cis form to the trans form. After that, it will give a nerve impulse and send a signal to the brain, right? And so the vitamin A forms the molecule, the rhodopsin. Do you remember this? Okay, that is the whistle pigment, the light absorbing molecule. At the in the photoreceptor. And after that, it absorbs the light, it will generate a nerve impulse and then send it to the brain. So this nerve impulse, users say should be the vitamin A. We need the vitamin A bind to the protein, the opsin, and then it forms rhodopsin so that it can absorb the light. Can you do you understand the whole process? That is what the vitamin A bind to the opsin, and that's the protein, bind it, and then form the molecule. That's the rhodopsin. This is the light absorbing molecule. After absorbing light, and then we'll have the changes in the shape from sixth form to the transform, and that will generate an impulse. So that, okay, it is detected by the brain. Do you understand the whole process? So here was the equation to, okay, I summarize the process. With the vitamin A bind to the protein, if I ask you what's the protein, then I hope you know it is the opposite. And then generate the whistle pigment. What's the whistle pigment? That's the rhodopsin, right? Rhodopsin absorbing lights. What's the change? Yeah, it will change the shape from the sixth form to the transform. Then we generate the impulse that is detected by the brain, right? That's the whole process. And now let's see the details. Here was the eyeball. Okay, I showed you, okay, the layer of the retina. And yeah, inside the retina we found the, okay, the rods and cones, and then the light pass through and now we'll have the rods and cones, and inside we'll have the what's that? We'll have the, yeah, we'll have the rhodopsin. Yeah, okay, that is the molecules, right? I just mentioned. And here's, well, the photoreceptors there, okay, with the whistle pigments, and absorbing the lights. After absorbing the lights, what's the change? Yeah, we'll change the shape from the sixth form to the transform. Then, yeah, we'll generate the impulse, right? A nerve impulse is generated. That's the black arrow. So the nerve impulse generated, and then and transfer, okay, absorbed, okay, detected by the brain. So here is the optic nerve, okay, and okay, send it to it, and then we will now, okay, we can see the things around us. And I would say, okay, on the retina, that is the layer in the eyeball. Okay, it contains many photoreceptors, around 125 million. And yeah, okay, and then, okay, there are two main types. One is rods, the other is cones. And these two types of photoreceptors, they have different function. They have different structures, they have different chemicals in it, and so the light sensitivity is different. Okay, now let me list them out. Show you the details. For the rod receptors, and these are the photoreceptors, right? Okay, and rod receptors, and we have the cells, they have the long cylindrical shape. On the handout, you find the diagram of it. Okay, please refer to it and take a look. And then there are many discs with the high concentration of pigment. To the rods is less sensitive to light. So that's why, okay, usually, okay, the main function is to detect the black, white, gray color, especially during the night time, or the light condition is a bit low and not enough light. So that, okay, we'll mainly use the rods to contribute to the vision. And this is the receptors, not for the coloration part, and for the a bit dull in color as the black or the gray color. Besides the photoreceptor, okay, if we just have the rod receptors, we can't see all the red, orange, all these colors. And so besides the rods, we have the cones receptors. For the cones receptor, okay, and its shape is different. It has the cone shape and with less distance, so that, okay, the concentration of the pigments is a bit lower. It's more sensitive to light. That means, okay, we need to, okay, absorb more light to produce the, okay, the nerves impulse, the signal. And it's for the color vision. Okay, with, okay, this information, and then now let's see the diagram of the rods and cones. You found these two you found, okay, these two pictures on the handout. For the rods and cones, you see, and for the rods, a bit cylindrical in shape. for the cone, okay, oh yeah, we'll have the cone shape like. And you see the disc, this is right, the disc. And so the vitamin A will bind to the protein, okay, and that is the opsin to form the rhodopsin, and that's the whistle pigment in the ROS, okay, so that it will absorb the lights, so that it will change the shape and generate the impulse. So you will find, okay, the protein is stored in the disc, okay, and then okay, absorbing the light, and then will generate the rhodopsin. That's the whistle pigment. So that okay, it can absorb the light, and then okay, will generate the impulse at the end. You know, vitamin A is important to us, but it's estimated that there are around 1/3 of children under age 5 around the world. They have okay the deficiency of vitamin A, and lacking of vitamin A will lead to night blindness. Okay, highlight this, night blindness. That means okay, during the nighttime you can't see the things clearly, with the impaired vision, particularly in the reduced light. And that's a problem, right? During the dark environment, if vitamin A intake is not good enough, and then we may not be able to see the things clearly. Vitamin A, you know, not just for seeing, for vision, it's also required for the skin repair and bone growth. Yeah, vitamin A is important, but if you take in too much, that's a problem too, and toxic in excess. Because vitamin A is fat soluble, and to dispose it takes a little bit longer time than the water soluble one. So if you keep intaking vitamin A in a large amount, and then it will just accumulate, may not be able to dispose it okay quickly. So it will allow the toxic levels of vitamin A to accumulate inside the body, and that will be a problem. So this graph, okay, it shows you if we have in the normal intake, then okay, all the things that will be okay are fine, right? With the proper maintenance of the epithelial tissues and immune function and light and color vision, all these with the proper function. And if the vitamin A is at a normal level. But if okay, it's not good enough, I just shared with you what we have the light blindness. Too much a problem as well. And don't think that okay, taking in okay, vitamin A is good, and then okay, eat a lot, okay, that will be a problem. So if it's too much, we have liver toxicity. Okay, the burden of the liver okay increase, and may have the redness of the screen. Okay, maybe okay, there's a loss of the hair. Dermatitis is another problem with excess vitamin A. Here, you know, okay, there's several countries they have okay, issued the new dietary reference intake, and this new dietary reference intake, okay, we use RAE to measure the vitamin A. Before we use the international units, but nowadays okay, we will okay change it to RAE to describe the vitamin A intake amount. In, for example, in the United States, Canada, Australia, they are okay now again using this new reference intake. It is recommend that okay for the men, for the women, okay, the intake is around 900 micrograms, 700 micrograms respectively. You know, okay, the intake of vitamin A should have okay a difference among the ages. Let's see here the table. Okay, and also okay there's a difference in okay and gender, right? So different ages, okay, the amount of vitamin A needed, okay, that will be different. Men and female, okay, men and women, okay, they should have different intake as well. But for the Chinese, the dietary reference intake is around recommended at the range of 800 microgram and 700 microgram for men and women respectively. So now we are in the age 14 to 50s, right? Okay, probably okay, it's around 900 microgram RAE, and 700 microgram RAE for male and female. In this table, lists out the food examples. Okay, containing vitamin A. From the list, can you point out which one has the highest content of vitamin A? Yes, that is the best liver, right? For around 3 ounces, and the intake is around 6,582 microgram RAE, and mcg, that is the microgram. Do you still remember what's the recommended value for the RAE? Let's say take male as example, as a reference. Yeah, around 900, right? So, wow, just 3 ounces of beef liver is over 900. 900 microgram is the recommended value, the intake value. And so if you check 6,500 over, check. Okay, and so it's more than 7 times. All right, so let's check. 6,582 divided by 900. That is, yeah, around 7.31, and that means, okay, it's 7 times more than we need recommended intake. And so if we convert this to the daily, the percent daily value, and it's around 731%.
If international unit is used, we will take 22,175 divided by 5,000. 5,000 is the reference point. So here is the equation I showed to you. That's why on the table you will see 444 as the percentage daily value.
Consider, okay, this, take 900 as the reference, and then take the RAE preserving of each food example and divided by the 900. Then you will get, okay, the ratio. Take this ratio times 100%, and that is the percent daily value. Okay, I would say RAE is the new labels, and is, okay, recommended, okay, using it, okay, start from 2020. The Food and Drug Administration require all manufacturers to use these new food labels to say the vitamin A content instead of using IU. IU is the international unit. Okay, we use it before, but nowadays it's replaced by RAE. Let's see a food example. Here, with a bottle of vitamin A supplement and from each soft gel, and the amount of vitamin A is 4,500 microgram RAE, right? If we take 900 as a recommended value, so 4,500 divided by 900, and then you will get 5 times. So you found that the daily line, okay, the daily value percentage, and that is 500%. But you know, as I said, vitamin A, we can't take in too much. The tolerable upper intake level is around 3,000 microgram and per day. So if, okay, every day we take in 1 gel, I think that's too much. You will find that, okay, for the retinol, okay, there's an upper intake level, but there's no upper intake level for the vitamin A, okay, carotenoids, because, okay, carotenoids, okay, it can be converted to retinol, in our body. And you liver, okay, with this super function control the conversion of the carotenoid to retinol. So for the carotenoid, there's no upper intake level, but for the retinol, there's an upper intake level. Got it? Okay, there's a news reported a long time ago, but okay, I think okay we can take it as a reference and keep it in mind as well. You know, okay, a girl, right? Okay, with too much intake of vitamin A, and then okay, finally, okay, that's a problem with the the liver, and if okay, we keep okay, taking in vitamin A for a long time, and then okay, as I said before, it is toxic. It is toxic. And that's all for the vitamin A. Any questions?